All right, you guys, let's look at section 11.4. We're going to find the areas of regular polygons and composite figures. So we're going to be using a little bit of that trig that we've learned in the past. We'll kind of go through the process here. So we used inscribed and circumscribed figures and found the areas of circles. So some of those concepts are going to come back again today. Find the areas of regular polygons, regular pentagon, regular hexagon, regular octagon, that kind of thing. And composite figures, so figures where we're combining several of these shapes together and adding up the areas, okay? So, the center of regular polygon. So if I take a circle and I circumscribe it about a polygon, okay? And I'm gonna do my best to sketch this here. This isn't gonna be perfect, but let's say I put my, part of my polygon at least inside of that circle, okay? The center of that is going to be the center of that inscribed polygon would be the center of the circumscribed circle, okay? So that would be an example of the center. The radius of the polygon goes from the center to the edge of the circle, so it ends up going to a vertex, okay? So this is going to be your center, that's your radius, okay? An apothem is a line segment that goes from the center of the polygon perpendicular to a side, like so. So this is your apothem. The central angle of the polygon, okay, if I draw in another radius and then I give these an A and a B, the central angle here is going to be angle ACB. Okay, and that's going to be important for finding some of the sides that we need. Okay, we're going to be spending some time finding perimeters of those and that apothem, and it's going to be important for us to find this central angle. Okay, and a composite figure has nothing to do with what we just talked about. That's just a figure I might put like a track where you've got a rectangle with half circles on the end. Okay, and we're going to then find the area of each of the small parts and put them together, add them up. Okay, so in the figure, pentagon PQRST is inscribed in circle X. Identify the center, a radius, an apothem, and a central angle of the polygon. Then find the measure of the central angle. Okay, so let's go back here. The center, that's going to be X, okay, because it's the center of the circumscribed circle. A radius, you've got a couple options, XQ or XR, because you have to go from the center to the edge of the circle. The apothem, the only apothem drawn in there is XN, because it goes from the center perpendicular to a side. And a central angle, angle QXR, that's this angle right here. And then we're supposed to find the measure of it. Well, if I drew in the rest of those triangles, I mean, I could keep drawing in triangles here. Okay, we would end up with 5 congruent triangles, each that has the same central angle. Well, since there's 360 degrees going all the way around that circle, if I take 360 divided by 5, because there's 5 sides in this pentagon and there's 5 central angles, I would get the measure of that central angle. So in this case, center X, got a couple radii, got the apothem, got the central angle, and then the measure of it, we're going to take 360 divided by 5, because there's 5 sides, and we're going to get 72. Okay? So why don't you guys give this one a shot? Similar situation, this time you've got a hexagon. Find the measure of the central angle. Okay? So there are 6 equal triangles this time. So if I take 360 divided by 6, because we're dealing with a hexagon, you would end up with the measure of your central angle, which is going to be 60 degrees, or B. Okay? All right. What about this? You've got this hexagon here where we've drawn 6 congruent triangles. Okay, so the top of a table shown is a regular hexagon with a side length of 3, then put that at the top, and an apothem of 1.7. What is the area of the tabletop to the nearest tenth? Well, the only tool we have right now is to find the area of one of those triangles and then multiply it by 6, because there's 6 congruent triangles. And that's not actually too bad, because that apothem right there is the height of that triangle. And the base of that triangle is 3, because if this is a regular polygon, all of the sides have to be congruent, so that's 3 as well. So I can find the area of that triangle pretty easily, half base times height, half of 3 times 1.7, and then I can say, hey, Well, why don't I just multiply that by 6 because there's 6 of those triangles. So that's what we're going to do. Okay, so find the area of one triangle, half base times height. We said our base was 3 and that apothem was the height, 1.7. So you multiply that out and you get 2.55 square feet. That's one triangle. Well, there were 6 triangles there, so the area of that whole thing would be what I would get when I multiply that by 6, or about 15.3 square feet. That's one way to find the area of that regular polygon. Okay, so why don't you give that a shot? Okay. All right, so step 1, we're going to find the area of just the triangle, and that's half base times height, which is 1/2 times 2 times 1.5. Half of 2 is 1 times 1.5 is 1.5. Okay, so that's the area of one triangle, but the area of the entire hexagon is going to be 1.5 times 6, because there's 6 of those. And 6 times 1.5 is 9 square feet. So that's one way to find the area of that entire hexagon. Now, another way is this formula that we're going to see here. If you have a regular polygon, in other words, all of the sides are congruent, all of the angles are congruent, that's important. One way to find the area is to take half of the apothem, which we talked about, that's this perpendicular segment, times the perimeter of the entire polygon. Because it's really half base times height, in this case because it's a pentagon 5 times. It's the same thing that we're doing in the previous slide. So I need the apothem and I need the perimeter if I'm going to find the area using this formula. So what about this scenario? Okay, so half apothem times perimeter. I don't have the apothem here at all. That dashed kind of pink line is not given to me. I can find the perimeter easy enough. If one side length is 5 and there's 6 sides, the perimeter is 6 times 5 or 30. But how am I going to find the apothem? Well, let's start with the central angle. The central angle is 360 divided by 6, because there's 6 equal triangles here, which is 60 degrees. And when you drop the apothem down here, you divide this in half. So half of 60 would be 30 right here. Well, that gives me a 30, 60, 90 triangle, you guys. Okay? And this 5 is also broken in half. So this is going to be 2.5 here and 2.5 here. So if you go back to chapter 8 with your 30, 60, 90 stuff. So I've got the short side is 2.5. To get to the long side here, I have to take 2.5 times the square root of 3. Okay? And so now I've got the apothem. That's going to be that segment that I drew in there. And we said the perimeter was going to be 5, one side times 6, or 30. Well, now that I know the apothem and the perimeter, I can go ahead and throw it into that formula, half apothem times perimeter. And so that's what they're going to walk you through here. Okay, so the central angle measure was 60. That's this angle here. We broke it in half because we dropped the apothem down. Okay, so half of that side length was 2.5, and then we multiply it by the square root of 3 to get to that apothem. So 2.5 square root of 3 is the apothem, and the perimeter we said was 30. So now we just need to put it into the calculator and see what we get. About 65 square meters. Okay. All right. What about this one? Now this is a pentagon. I don't have the apothem on this one, and I don't have a side length either. So I'm gonna have a little bit of trouble finding both. But I am going to start with the central angle. I think that's important. So there's 5 sides. 360 divided by 5 is 72. Okay. So this entire angle here, if I were to draw it in another one, this entire angle is 72 degrees. When I drop the apothem in, though, I'm finding half of that. So this is going to be a 36 degree angle right here. Well, I do have a right triangle in there then. And what I really need to find, okay, I need to find x, we'll call it, because if I double x, I've got a side length, and then I can find the perimeter. And of course, I need to find the apothem, okay? Well, compared to the 36, x is opposite, and the radius there is 9, okay? So opposite and hypotenuse is sine, so I'm going to use my trig stuff here. And the apothem is adjacent, and the 9 is the hypotenuse. So that's going to be cosine, adjacent over hypotenuse. Okay? So when we get going here, the sine of 36, because we broke that 72.5, was opposite, which was dB, that was the x I drew in the previous screen, over 9, which is the hypotenuse. And the cosine, CD, which is the apothem, that was the adjacent side over the hypotenuse. So our math here, 9 times the sine of 36, 9 times the cosine of 36, is going to give me those two values. Okay? And so, if dB was 9 times the sine of 36, AB, which is one whole side length, remember dB we broke into one little part here, okay? And so if I double that, I get one side length. And then if I take that side length and I multiply it by 5 because it was a pentagon, I've got the entire perimeter. Okay, so I can work through that. And the apothem was that 9 times the cosine of 36. Okay, so there's your apothem, there's your perimeter. I can work it out and I get an approximation of 192.6. Okay, we'll try a couple of these together here too. All right, so find the area of a regular hexagon round to the nearest tenth. So again, 360 divided by 6 gives me 60. I break that in half, I've got 30. Okay, one whole side was 7.5. So when I break that in half, I've got 3.75 for each of these parts. Because I have a 30, 60, 90 triangle, my apothem here is going to be the short leg, which is 3.75, times the square root of 3. That's my 30, 60, 90 information from chapter 8, okay? And my perimeter, okay, one side was 7.5, and there are 6 sides. So 7.5 times 6, I think is 45, but I'll check, yep. Okay, and so then my area is going to be 1/2 times my apothem, which was 3.75 square roots of 3, times my perimeter, which was 45. So 0.5 times 3.75 roots of 3 times 45, I get like 146.1, I get D here. Okay? Okay, so that's fine and dandy if you get a nice 30, 60, 90 triangle. What if you don't? What if you're dealing with a pentagon here? So again, 360 divided by 5, because there's 5 sides, is 72. Half of 72 is 36. Okay? So, let's find the apothem here. So compared to the 36, apothem is adjacent. So the cosine of 36 is equal to A over 7. So that's how I'm going to find my apothem. Okay? So I'll go ahead and just do the math on that. 7 times the cosine of 36. I get about 5.66. Okay? Now, I'm also going to need to find, let's call this B. That's going to be half of the side length. So the sine of 36 is equal to B over 7. So B is going to be 7 times the sine of 36. I get about 4.11. So then the perimeter, if this is 4.11, I have to multiply it by 2 to get the whole length of the side, and then I'm going to multiply it by 5 because there's 5 of those sides. So the perimeter is about 41.14. Okay? And so then the area is 1/2 apothem times perimeter. So in my calculator, 1/2 times the apothem, which we said was 5.66, times the perimeter, which was 41.14, or 11 actually, okay? I get 116 point, about 0.5 if you round it out, okay? So you do have to use a little bit of trig to find some of those unknowns. All right, so what if you have a composite figure like this? What is the area of this thing? Okay, well I've got a rectangle here, base times height, and I know the base is 32, the height is 16, I can find that easy enough. I've got a triangle where the base is 32 and the height's 15. I've got everything I need to know there. And then I've got two half circles that if I put them together, creates one circle. And I just need the radius to find the area of a circle. Well, if the diameter is 16, the radius is 8. Okay? So when we look at the next screen here, we've got a rectangle, a triangle, and a circle. Okay? So base times height is the rectangle, half base times height is the triangle, and pi r squared is the circle. So the rectangle was 16 by 32. The triangle was 32 by 15, half base times height, and the radius was 8 for that circle. So if I add all of those together, I get about 953.1. Okay? So why don't you guys try one of these, see what kind of weird shape we've got here. Okay, and then I'll plug them in together. So our total area, let's look at these triangles. So triangles half base times height. And we have two of those, okay? You've got a rectangle, which is base times height. And then you've got a semicircle, which is going to be half pi r squared, okay? So let's work this out. For our triangles, our base is 5 and our height is 8. 1/2 times 5 times 8 plus 1/2 times 5 times 8. For my rectangle, I've got an 18 by 8. And for my half circle, I've got 1/2 times pi. The radius here, if the diameter is 18, the radius is 9. Okay? So then let's work out the pieces here. Half of 5 times 8, okay, is 20. So I've got 20 plus 20. 18 times 8 is 144. And 0.5 times pi times 9 squared is about 127.23. Okay? Well, now let's add all those together. So 20 plus 20 plus 144 plus that 127.23. I get like 311.2. Okay? So you break it up into the parts that you can find the areas of, and then you work it together. Okay? So, how about this one? Find the area of a shaded figure. Well, in essence, the shaded part is the big triangle, or the big rectangle, sorry, minus the part that's not shaded. So I'm going to take the big rectangle minus the little rectangle. And so if this was 100 and I added 25 to each side, 100 plus 25 plus 25 is 150. So the dimensions on this outside are 150 here. This was 20 plus 25 plus 25, 50 plus 20 is 70. So the area of the big rectangle is 150 times 70. The area of the little rectangle is 100 times 20, and I'm just going to subtract them, okay? So 150 times 70 minus 100 times 20 gives you about 8,500 square feet for that shaded region, okay? Why don't you guys try one like it, okay? Very similar situation. So the area of the big rectangle is going to be 18 times 10. They give us the dimensions on this. Minus the area of the little rectangle, which is 6 times 4. Okay, so 180 minus 24, which is 156 for B. Okay, not too bad. All right, there's your assignment, you guys. Pretty small today. Page 11, 811, 9 through 23, the odds. Good luck.